Hey everyone, welcome to Carbon Radio. Today I'm going to go through how to fairly and transparently balance a budget with input from 535 politicians. This is meant to simplify and simulate how we might get to a balanced budget with 435 members in the U.S. House of Representatives and 100 members in the U.S. Senate. So I'm going to go through this example and then see what you think. So I've outlined this in 5 steps. The first step will be for every member of the House and every member of the Senate to submit a budget to the Congressional Budget Office. This can be submitted in any format, but ideally the Congressional Budget Office will have a format that asks for percentages. But in this example, I'm using 3 House members. So the first House member submits a budget, and these are the 3 line items, one for puppies, one for kittens, and one for turtles. And they say this is the amount of dollars I think should be spent on each of these. So $100 for puppies, $200 for kittens, $50 for turtles, totaling $350. Then the second House member submits their budget, and they submit it in percentages. And they have 4 line items. One is for puppies, one for kittens, one for turtles, and one for kangaroos. And they allocate based on percentage, 20%, 10%, 2%, and 68% respectively. And then House member number 3 comes and submits their budget with 2 line items, one for owls and one for falcons. And they say that the budget should be $1,000 for owls, $2,000 for falcons, totaling $3,000. So you immediately see some of the problems that might arise. You have 2 different budget numbers and one in percentages. So the question is, how do you synthesize all this in a fair and transparent way? Which is what I'll do here in the House Synthesis tab. So the second step in the process will be to convert all of the budgets into percentages that add up to 100%. So you'll see for House member number 1, the total budget is $350. So what we're going to do is take the line item and divide it by the total budget for that congressperson has submitted. So in this case, the puppies have been allocated $100. The total budget for this congressperson is $350. So we do 100 divided by $350 to get the percentage of 29%. You do that for all 3, and that gets you a budget that adds up to 100%. The second House member had already submitted in the form of percentages, so they're all set. And then the third House member, we do the same thing where we divide the number for each line item by the total budget. So now we have 3 budgets in the form of percentages, and we can move on to the third step, which is to aggregate these budgets proportionally. So first we assign a proportion of the budget to each House member, and in this case we have 3 House members, so we're assigning them equal budget amounts. So each House member gets a third of the budget, 1 divided by the total number of House members in this example. In the actual simulation, it would be 1 divided by 435 House members. So each House member would get 1 divided by 435 as their proportion. But in this example, we're just using a third to show how the simulation would work. So we're going to take all of the different line items that have been submitted, and you can see there are some common line items between House member 1 and House member 2. So those will be aggregated proportionally here. So what we're going to do is we're going to multiply the House members' proportion by the proportion that they allocated for that line item. So for example, puppies, in House member number 1, in their budget, they allocated 29%, and that House member's proportion is a third. So we're going to multiply a third by 29%, and then we're going to add it to what House member number 2 has in their budget, which is 20%. So adding 20% times their proportion, a third. So you get this calculation here. You see the B15 cell is House member number 1's budget multiplied by B24, which is their proportion, adding to E15, which is House member number 2's budget line item multiplied by their proportion, which is B25. And what you get is a fair and proportional aggregation of that line item, which comes out to 16.19%. And if you do this for every line item, multiplying by what each House member has in their budget and their proportion, you should, at the end of this, have a budget with percentages that add up to 100%. So when you do this, you do the summation of all of these. And if it equals 100%, you did the process right. So we have 100% here. All of this adds up to 100%. This is how the House budget would be finalized. And then you'd move on to the next step, which is to aggregate the House and Senate budgets proportionally, which I do here in the last tab, House plus Senate tab. So in this process, we allocate 50% of the proportion to the House and 50% to the Senate. And we do the same process. So we take the two budgets that just went through the step 3. You have a House budget and a Senate budget. I made up the Senate budget, but you can imagine it going through the same process. And so you have these two different budgets, and we have to bring them together and aggregate them proportionally. And we have to bring them together and aggregate them proportionally. So the process here is the same. We're going to multiply the 50% by the first line item and add to 50% multiplied by the first line item in the Senate budget, and we get this number. And in the same way as the last tab, these numbers need to add up to 100%. So we look at a sum function of all these different things, and if it adds up to 100%, we did it right. And then we can move on to step number 5, which is to convert this budget into dollars. So we have to make some sort of assumption, or we have to be told what the total dollar amount is that we have available. Maybe it's the previous year's tax revenue, which I have an example listed up here in cell G2. Or you can say that the Congressional Budget Office just gives you a number of what's the dollar amount available for this year's budget. And then you just do a simple multiplication of the line items percentage multiplied by the available budget. So you see here we have 10.6% allocated for puppies. We multiply it by the total amount budget available, and we get the dollar amount that will be spent on that line item. We do that for every line item. And then similarly, when we total this up, it should equal what the given budget amount is, which means we have achieved a balanced budget. So this is the kind of simplified simulation of how to achieve a fairly and transparently balanced budget with input from 535 politicians with competing interests. So let me know what you think in the comments. Does this make sense? Does it even make sense in terms of the simulation? Does it make sense as a policy? What do you think of this? And I'll see you in the next video.